My name is Eugene Suyu. I'm the CEO and one of the co-founders of Tinkerine Studios. We at Tinkerine build 3D printers. We manufacture them and we design them right here in-house. And we make sure that they go to K-12 schools across Canada so that they can help students pick up 21st century skill sets. Tinkerine's been around now for 8 years. We've been developing the product and serving the education industry for, about that long. What we focus on at Tinkerine are what makes it easy for teachers to use, what they care about the most. So we focus on reliability, so they can easily print overnight if they need to. We focus on speed, and then we focus on ease of use. In 3D printing, we can print absolutely anything. Anything the mind can imagine, really. The only thing that's really the barrier is the student's ability to get the skill sets to make them. It's what they can actually imagine, they can feel, and they can touch. For the very first time, we didn't have a technology like this before. So they can now do that, right? And this process can now be condensed in such a small session that you can actually do this at a grade 4 level. And the students can have something that they can touch and they can feel, and they can make mistakes along the way, but then do it all over again because it's so fast. They pick up these skill sets, and when they join the workforce, they translate all of that for the businesses. And now the businesses can run faster, more efficiently, innovate on new things that they couldn't before make. All because now we've got a technology that does it for them instead of having them spend the time building the object. They now conceptualize the object. So from the manufacturing side, what we start off with is building the foundational skeleton. We start off with step 1 of gantry. We want to make sure that the motion system is in place. Once we have that, we then wrap the shell around the gantry to build the overall skeleton of the machine. And then we start putting little infrastructures in place, like the spine, like the bed, and the base. And once that's all there, we have to put the most important part in, which is the carriage. The carriage houses what the actual print head is. And so we install that. And once that's in, we can go ahead and put the electronics, which is the brains of the 3D printer, that will control the rest of the machine. We wire all that up, and then the base goes in, and we calibrate. Once the calibration is done, then we can start to print the little objects that we use for calibration tests, endurance, and making sure everything is good. And off to the races we go, packaging that up, getting it to the customer. So the Little Pro and the material that it uses is called PLA. It's a biodegradable plastic that is safe for the classroom. And there's a common thing here that we do at Tinkerine is that it's all for the teachers, and we need to ensure that safety is number 1, especially when it deals with students. So the machines themselves are certified safely electrically, and the material that we chose is also safe for the classroom. And we wanted to ensure that it was also biodegradable because we're creating these plastic objects, so in the event that they end up in a trash can or somewhere, they should be able to biodegrade down to nothing over a period of 3 months, 6 months. We're going to do some push into the post-secondary industry for where we want to go, because as students graduate in the K-12 market, they have to go to post-secondary or usually end up in post-secondary. So we want to ensure that they continue to have the tools to be able to push this technology even further. Maybe even more materials as well, so composites or carbon fiber or metal, whatever it may be, right? So that's where we're going, with the eventual goal that we get one of these into the hands of every designer, every engineer, every business, because I think that's where the potential really is at the end of the day, to be able to help us innovate more. Biomedical, engineering, communications, you name it, this technology has a place in those industries and beyond.